This video is on solving radical equations. A radical equation has a variable in the radicand or a variable with a rational exponent. To solve a radical equation, isolate the radical or the expression with the rational exponent to one side of the equation. Raise each side of the equation to the power suggested by the index or the exponent. Solve the remaining equation and check your solutions. Let's take a look at several examples here. We need to solve each equation and check your solution. It's really important that we do check our solutions because sometimes we can end up with an answer that doesn't work. So number 1 has the square root of x plus 4 plus 6 is equal to 7. First step is to isolate our radical. So I'm going to subtract 6 on both sides, and that gives me x plus 4 is equal to 1. Now, since I have a square root here, what I want to do is I want to square both sides of the equation. So squaring undoes the square root. So I have x plus 4 is equal to 1. And then subtracting 4 on each side, I have x is equal to negative 3. But before I box that, I need to check that and make sure it works. So I want to plug that back into the original equation for x. And remember that when we are checking an equation or checking a solution, we don't act as though we're solving it. Like, for example, I would not subtract 6 on both sides. I want to use order of operations on each side. So this is going to give me the square root of 1 plus 6. Is that equal to 7? And indeed it is. 7 equals 7. So my solution is x equals negative 3. Second example says 2 times the quantity x plus 3, which is raised to the 2/3 power, equals 8. So I want to isolate my expression that's raised to the rational exponent, to the 2/3 power. So I'm going to divide both sides by 2. So x plus 3 to the 2/3 power is equal to 4. And now in order to undo this 2/3 power, I'm going to multiply each side of the equation by, or not multiply, but raise each side of the equation to the 3/2 power. So why did I do that? Because I'm going to use my power of a power property. So something raised to the 2/3 power raised to the 3/2 power, I multiply my exponents, and that gives me x plus 3 to the 1 power, or just x plus 3. 4 to the 3/2 power, I'm going to write 4 as 2 squared to the 3/2. That's going to give me 2 to the 3rd power. So I'm going to move my work up here. So I have x plus 3 is equal to 8. So x is equal to 5. So let's go ahead and check that in the original equation. So 2 times 5 plus 3 to the 2/3, is that equal to 8? So is 2 times 8 to the 2/3 power equal to 8? 2 times 2 to the 3rd to the 2/3. It's going to be 2 times 2 squared. Is that equal to 8? So that's 2 times 4. That is indeed equal to 8. So it checks. So x is equal to 5. And our last example here is the square root of 5x plus 14 equals x. So my square root is already isolated. So I'm going to go ahead and square both sides. So that gives me 5x plus 14 is equal to x squared. And I like to keep, if I'm noticing that this is a quadratic equation because it has an x squared, I like to keep my x squared positive. So I'm going to write this as x squared and subtract 5x from both sides, subtract 14 from both sides, set it equal to 0 since it is a quadratic equation. Factor this to x minus 7 times x plus 2. So that's going to give me two solutions, x equals 7 and x equals -2. And actually this is the case where you're squaring both sides and you end up with a quadratic, where you might end up with an answer or possibly both of them won't work. So we need to check each one. So I'll start with 7. Is the square root of 5 times 7 plus 14 equal to 7 squared? Is the square root of 35 plus 14, oh wait a minute, no, it's not 7 squared, just 7, sorry about that, equal to 7. Is that equal to 7? Yes, because that's the square root of 49 is equal to 7. That one does check, so x can equal 7. Now let's try -2. Is the square root of 5 times -2 plus 14, is that equal to -2? So is the square root of -10 plus 14 equal to -2? No, the square root of 4 does not equal -2. Remember, we talk about the principal square root. The square root of 4 is equal to a +2, so x cannot equal -2. So in this case, I have just one solution. X is equal to 7. So in this video, we took a look at how to solve radical equations, including those that may not necessarily have a square root or a cube root, but could have a rational exponent, by isolating the radical or the expression that is raised to the rational power, by getting rid of that square root sign by squaring both sides, or as we saw in the second example here, raising it to a power, raising our expression to a power that makes the exponent 1. And then solving that, and very important, check your solutions, because you can, as we saw in the last example, you can end up with a solution that does not work.